Hi everyone, my name is Dipankar and I'm a developer advocate here at Remu. Today we are going to look at a blog and walk through the steps that basically would help data practitioners and data engineers get started with a lakehouse architecture, basically a minimalistic lakehouse architecture. And the expectation is that we want to do the same type of data warehousing capabilities in the data lake. So if you're looking for a quick and easy way to get started with the lakehouse architecture and just try out a few things, this might be an easy way for you to do that. We also have supplied a Docker image as part of this particular blog. So what you can do is you can just run this particular command and you will have an environment with all the setup that we want to use for this particular experiment or project. And we also have supplied the notebook that we have used for this particular blog. So you basically have a templated form of all the configurations and you can supply your own parameters and configurations, and then you can play around with whatever you want to do. So let's get started. So the first thing in this particular setup is there are a couple of components that basically helps us achieve this lakehouse architecture, right? The first thing itself is the table format. So the table format is the core component that allows us to have those data management capabilities in a data lake. So the ability to do DML, like time travel, or do things like compaction. Those were there in data warehouse previously, right? And we are expecting the same thing to be able to do in a data lake. And the table format facilitates those things. The second important component is called the catalog, and for working with Iceberg tables, we need to have the catalog defined initially, right? This is the component that basically brings in all those ACID guarantees to any transaction in Apache Iceberg, right? So this is a very important thing. For this particular demo, we will use something called Project Nessie, which is basically a catalog, and you can use other catalogs as well, like AWS Glue, DynamoDB, REST catalog, whatever it is you feel like. The third important component is the processing engine, which in this case would be Spark, or the Python binding, which is PySpark. And that will be used, we'll use that particular engine to create Iceberg table and do all sort of DML operations. And finally, all of our data will be stored in a data lake. It's already in a data lake. So we are going to use a S3 bucket as a data lake. So this is our overall setup, right? So the next important part is the configuration itself, right? The configuration is super important because we are bringing in Apache Iceberg, we are bringing in the catalog Project Nessie, and we want to do everything using PySpark. So in total, there are around 10 configurations that I basically listed out, and each and every one has a specific purpose. For example, we need to make sure there are this Spark runtime and Nessie Spark extension for Iceberg. Those are defined in that particular configuration, and as you can see in this particular notebook, we have those defined over here. Similarly, we need to define a catalog, and we need to make sure that everyone understands that this is a Nessie catalog, and that's what we do over here. We create a catalog named Arctic, and we say, hey, this is a Nessie implementation, so it's a Nessie catalog, right? Another important thing here is to we are going to use Spark to create Iceberg table. That means we are going to write a lot of things to this particular bucket. So in this case, that will be our S3 bucket, which you can define, And then we also need the URL of that particular catalog, which in this case is Nessie, or the service around that. It's basically Remu Arctic. Once we have that, we also can select the authentication mechanism. In this case, I'm going with bearer, but you can also select none, and you can not choose to have an authentication. Once we have these particular configuration, we set the extension for both Nessie and Iceberg, and finally we can run this particular block of code. And once everything runs, you should see something like this particular artifacts getting downloaded, and that means that you're ready to start with your lakehouse architecture. So those are basically the 10 configurations that are there as part of this particular setup. Okay, and in terms of the notebook, like I said, that's basically the configuration. Those 10 configurations are basically defined over here. Once we run that, we should all be good to do our own things. So for example, we can do things like let's list out all the references in this particular catalog. All those different branches that we have. So the best thing about using Nessie over here as a catalog is that it brings all those Git-like branching abilities. Like you can create your own branch, and you can separate the work as you want, and you can basically do isolated data related work. So for example, you might want to do things like isolated ETL ingestion work, right? You might want to do separate it from the production data. That's a great use case. So Nessie helps us achieve those particular things. So as you can see, I listed out a couple of the references or branches that is present in, Nessie or Arctic. And these are the ones that we have right now. So you can create a new branch as you would like, and you can basically say, hey, create branch work in Arctic, and this will basically give us a new branch. And that once we use that particular branch, use that reference, as we can basically confirm that we are working in that particular branch and not the main one, which is supposed to be the production one. So once you create the branch, what you can do, the first step would be just to create an Iceberg table. And, it's as simple as creating CDS. It's basically, you can use different ways to create Iceberg table. For example, here I'm using something like create table this, and, I'm defining a couple of the columns over here, and I'm saying using Iceberg. That means I'm using an Iceberg table. And then I'm inserting some new data from a CSV file. In a real life, in a real world scenario, this might be data coming in from the data ingestion team who are ingesting new data over here. So just to replicate that, and once we have that data, we can insert it into that particular catalog, particular table. Okay, and once we have that particular, I'm not running this particular command because I already have this. So what I have to do is basically read the value. So let's see and run this particular command. And if I do like a select star from this particular table, I should see the data that I just ingested in the Iceberg table. So this would basically mean I would basically be able to read the data. We inserted the data, which is a write operation, and this is the way we are reading the data. And as you can see, we have the data, as from the Iceberg table. Now, if you want to do some DML operation, for example, you want to update the table with the new data, you are free to do that. It's as simple as using SQL and updating the table. And that's basically all we need to have that particular setup that we want to do for our lakehouse architecture, right, in general. So this is what I have basically written over in this blog, and I walk through a couple of operations and basically go through what happens in each of these operations, and like updates and reads and those kind of stuff. So there are also a couple of important added benefits that come with Iceberg tables. For example, there are this metadata table, right? You can basically query the metadata table separately in Iceberg. For example, you can, for example, if you want to see all the files that are there, you can just say, hey, select star from this particular table.files. And basically Iceberg will give you all the files that are present in this particular directory. That is basically in our S3 bucket, which is our data lake. So those kind of things are also, there, and it comes as part natively with Iceberg. That's really advantageous. For example, we can see this particular file path in our in our environment, and then we can also see the upper bounds and the lower bound of the columns and those kind of metadata details, right? We can also see the history over here, what time we made the commit and different snapshots that we are kind of having over here and those kind of things. So that is basically that kind of leads to having a lakehouse architecture. And, like I said, it's basically you have the notebook and everything that I kind of supplied through this tutorial. And it's a very easy way to get started and play around. And before we put something to production, it's very important to have that mockup. And, it's important to try out these new things. So that's the whole idea behind this tutorial. Hope you guys like it. Thank you so much for watching. Bye.